Today is February 18, and we're the day before the major renovation of the new pressure vessel system, which is going to come up onto the roof tomorrow. This is our lab right now. Our lab is on a penthouse, which is called the 5th floor of our Van Leer building. And right here we have the legacy pressure vessel system that we've been using for the past 3 years for the Juno project. And actually this system, as you can see, is a pressure vessel inside an oven. Inside the pressure vessel are 2 microwave resonators, and as you can see inside, they're connected via high temperature cables. I'll let Brian close the door so that the temperature has a chance to re-equalize. This is a big deal. Stabilizing the temperature takes hours and hours. You can see we have gas bottles, both outdoor for the storage of the high pressure hydrogen helium, and indoor for our argon, which we use to dielectrically match the resonant measurements. The large resonator, which will be conducted with we also used in the new system, will be done with this Agilent 5071C network analyzer. Measurements of the small resonator, which will not be included in the new high pressure system, are done with the spectrum analyzer and signal source that we show here that operate up to 40 gigahertz. This device right here is a Fabry-Perot resonator, which lets us analyze the gas by taking a sample out of the pressure vessel I just showed you. This allows us to measure the microwave properties of the gas mixture after it's already been in the pressure vessel for a while, so that if adsorption occurs, we can detect it by measuring the microwave properties between 26 and 40 gigahertz. In the system we just showed you, the pressure vessel was capable of handling 12 atmospheres, or 12 times the pressure of Earth's atmosphere inside it when it was simulating planetary atmospheres. However, the Juno mission will sense much deeper, much higher pressures in the atmosphere of Jupiter, reaching pressures as high as 100 Earth atmospheres. As a result, a new pressure vessel has been built, which you can see right here, which is capable of withstanding 100 times the pressure of the Earth's atmosphere, or approximately 1,500 pounds per square inch. This pressure vessel weighs 1,200 pounds, so it's not light. And as you can see, even though it has wheels, it's very, very hard to move around. This pressure vessel will be inside the new oven, which will be part of the Jupiter atmospheric simulator. You can take a look at the size of the bolts here. These bolts are nearly 1.5 inches in diameter, and there will be 22 of them all around the perimeter of the pressure flange, so that we can safely contain such high pressures. Well, with our pressure vessel and oven, we're going to be able to simulate the atmosphere of Jupiter. But the pressure vessel weighs 1,200 pounds, as does the oven. So we can't place inside our lab, which is behind this door, we can't place the pressure vessel and the oven together because they weigh too much. Fortunately, we have a reinforced concrete pad here on the roof. This reinforced pad is 4 feet by 4 feet. It has 14 inches of poured concrete, or reinforced concrete rather, and is able to handle 6,000 plus pounds, almost 7,000 pounds. So tomorrow when the crane comes, it will set the oven down on this pad. We also have metal plates here that we've just brought up. They're very heavy, and when we bring the pressure vessel up, we'll set it initially on these metal plates, and then we'll use our little gantry crane to lift the pressure vessel with the microwave resonator inside into the oven, which will be placed there. We've also bought a little shelter for the oven. Yes, here's the shelter. Well, not really. This is one of our labs full of junk. But you can see the shelter here called an Easy Shed, which we purchased recently. All the parts, some assembly required. And we'll build the Easy Shed around the oven so as to protect it from the weather. The new oven is ready to go up. The pressure vessel is now ready to go up in 2 pieces, the top plate and the main container. And the crane has arrived. used to lift everything. They're just putting the pedestals in position right now, as you can see here in the shadow. So, we'll be ready to go soon. Now the train is going up. As you can see, we're going up to the top of our building, or actually to the roof of the 4th floor of our building. Our lab is the 5th floor penthouse. So the train will be used to carry everything up. This, by the way, is our transformer. This is the device which will operate with the oven. Armored oven there. There goes the train ball. I think maybe it's time for me to put my hard hat on. Here comes the oven. $1,200 pounds of oven coming up to our roof. That's good. That's good. Maybe if you could lower it just a little bit. Perfect. That's fine. Okay, and follow Terry's signal. Comes the pressure vessel. 1,200 pounds.
I'm really surprised that thing didn't want to have a tendency to flip over.
That was one of the things, though, they worked on that. It's been specially strapped so it didn't flip. There it is. It is landed on the roof. It's jumping.
It's so happy.
It's so happy. It's jumping that it's at its final home here. And because of the special plates and the special decking under this roof, it is not crashing through the roof, which was a big issue. So here at last is the oven and the pressure vessel in their final location. A shed will be built over the oven once the pressure vessel is inside so that it will be weather protected. And all we have left to do right now is lift the transformer for the oven, and we're done. And here comes the transformer at a svelte 300 pounds. So it's not quite the heavyweight the others are. Now that the oven and the pressure vessel have arrived, we're beginning assembly of the protection, the weather protection for the oven. It's called an easy shed. And as you can see, some assembly is required. So Tom and Brian are going to try to knock this thing off before the next rainstorm hits. And with any luck, they'll make it. But as we said, something like 120 pieces. 45 minutes later, Tom and Brian and Karutha have completed the frame of the Easy Shed and are now aligning it. We had to be very careful to position it properly so that the doorway wouldn't block the opening to the oven. Now, about 2 hours into the process, Tom and Karutha and Brian are still working on the Easy Shed. And finally, after working well into the evening, the Easy Shed is complete.